Alright, hello everyone. So before we further move on in trigonometric substitution, we want to learn another specific strategy that we need to use in upcoming trigonometric substitution problems. In the previous video, in the previous problem that we solved, we didn't need that strategy. Okay, what is it about? Well, if you can remember, in the previous video we had our substitution to be x is equal to secant theta, and once we were done with the integration we got theta plus c as the answer, right? Now the thing is that you want to convert, you have to convert theta back into x, because your original problem was given in terms of x, so you have to rewrite your answer in terms of x. So what did we do here? Well, we just took the inverse, right? So we said theta is equal to secant inverse x, and that's correct. Okay, so our answer will be here secant inverse x plus c. Now you have your solution for the integral in terms of x, not in terms of theta, right? So you have to do that. All right, so let's look at this one though. Now here, let's say the substitution is x is equal to sine theta. Now I'm not going to solve a complete trigonometric substitution problem. Okay, I'm just going to give you the substitution and the final answer. Let's say that we did that all good stuff, simplify the square root and Pythagorean identities, all kind of stuff, and we got our final answer to be this. Now here, how can you convert this cosine theta back into x? So what most of the students do is they write 3 cosine theta is sine inverse x, cosine sine inverse x. Okay, now this is okay, but most of the teachers not gonna accept it, so don't do that. Okay, all right, so how can you convert correctly? Now you might ask, well, if it works here, why it doesn't work here? Okay, well, that's a separate discussion, but I'm not going to go into that. Here's the thing. If you just have theta without any trigonometric function, without sine, cosine, tangent, secant, if you just have theta like here, only theta, then you can use that inverse. But if you have a trigonometric function in your answer like cosine theta, it's not just theta, cosine theta, then you have to turn it back to x. Don't do that inverse. Here's how we do it. The secret, the key lies in the substitution. Always use the substitution, nothing else. Okay, now read the substitution. So here let's read it as sine theta is equal to x. Now draw a right angle triangle. Okay, and mark the right triangle and pick up any angle you like and name it as theta. Okay, all right. Now, what is sine theta means? What is the definition of sine theta? It is the opposite side over hypotenuse, right? So cat over, if you can remember. So cat over. So cat over. So sine opposite side over hypotenuse. So here's the opposite side, here's the hypotenuse, right? For this theta here. If you think here in terms of this theta, for this theta angle, the opposite side is here and the hypotenuse is here. But sine theta is here x. X is actually x over 1, right? You have 1 in the denominator. You can pretend you have a denominator, right? So opposite side over hypotenuse is sine theta. So what is opposite side length? Is x, right? And the hypotenuse length is 1. You can think it in terms of like that. Okay, so you use the definition of sine. Now what you want to do is you want to use the Pythagorean theorem to find the other's length of the other side. So what is the Pythagorean theorem says? Let's say this is a, so it says the squares of x plus square of a added is equal to the square of 1, which is 1. So a square is 1 minus x square. Okay, so a is actually take the square root of this side, so this is the length of the other side. Now you want to do that very carefully. You might do mistakes here. See what I did here? I wrote the Pythagorean identity here. Okay, Pythagorean theorem, x square plus a square is equal to 1. Then I made a subject. Okay, some students like this as 1 plus x square, try to do that in their mind. Please don't do that. Be careful until you get some experience, until you really get the gist of it. Okay, all right. Now why did I do that? Well, we have to write 3 cosine theta in terms of x. Now, what is cosine theta using the definition? Adjacent side over hypotenuse, right? So for this theta, what is the adjacent side? Square root 1 minus x square. And what is the hypotenuse? 1. We can pretend that 1 is not there. So this is the answer. This is how you convert back a trigonometric function into x again, okay, using the substitution and the triangle and the definition of sine, cosine, or secant, all those stuff. Okay, let's do another example because we want to do this as much as possible. We will be doing this a lot in trigonometric substitution problems. Let's do another one. Let's say you have x is equal to secant theta, and your solution is let's do this sine theta over 2 plus, let's say, sine 2 theta over 2 plus c. Okay, so how can we convert? Well, you don't have just theta, you have trigonometric functions in the answer, so use the substitution. So x is equal to secant theta. Wait a minute, what is secant theta? Well, secant theta is 1 over cosine theta, right? So actually, if you change the sides, if you do a cross multiplication, you get cosine theta to be 1 over x, right? Okay, so I rewrote secant theta in terms of cosine theta because we know the definition of cosine theta as opposite side over hypotenuse, and sine as cosine theta adjacent side over hypotenuse, sine as opposite side over hypotenuse. So always try to write them in sine and cosine when you have secant, but if you have tangent, it's actually opposite over adjacent, right? Okay, all right, so here let's draw the triangle. Here it's theta, here right angle. It doesn't matter where you put theta, but make sure you use the definition of the cosine theta correctly. So adjacent side is 1, hypotenuse is x here. Let's say this is a, so a square plus 1 square is equal to x. So a square plus 1 is equal to x square. So a square is x square minus 1. So a is square root x square minus 1. So the missing side is x square minus 1 square root. Okay, all right, so let's try to write here. This one is tricky. Sine theta is opposite over hypotenuse, right? Because for this theta, so it's square root x square minus 1 over x, divide by 2. Let's have this 2 here. So that's sine theta. Here's a special one. How am I gonna write sine 2 theta? Because this is theta, okay, not 2 theta. So do we have to do another triangle? No. Are we going to multiply this by 2? Like, I mean, are we going to multiply sine theta by 2? No. We have to use double angle identity here. Always remember, in your answer, you should have in terms of sine theta, cosine theta, not sine 2 theta, cosine 2 theta. You will always have to rewrite them in terms of thetas, okay, before you use this triangle trick. So sine 2 theta is actually, by the double angle identity, 2 sine theta times cosine theta. So it's 2 sine theta cosine theta over 2 plus c. Now this makes life easy, okay? So 2 cancel out, so this is square root x square minus 1 over 2x plus, what is now sine theta? We know that it's square root x square minus 1 over x. What is cosine theta? We know that it's 1 over x, adjacent over hypotenuse, 1 over x plus c. So let's simplify this little bit just to make it look nicer. So we can write this as x square minus 1 square root x times x square plus c. Alright, so this is the final solution. So that's how you do it. That's how you convert your final answer in terms of x. Okay, so you will always get this type of a substitute in a medium level trigonometric substitution problems, and those are the problems you always get if you are concerned about an exam or homework. Okay, so you have to practice this. I'm gonna do lots of problems in upcoming videos so you can learn it. Okay, all right, thank you very much. Then now we can move on to medium level trigonometric substitution problems. See you in next videos. Bye bye.